So in this video, we are going to continue our discussions on chapter number 6, lines and angles. So we are going to see an important property which is related to pair of interior angles on the same side of transversal. Okay. So first, let's try to visualize this. What does it exactly mean? So okay. So let's draw two parallel lines, and this is our transversal. Okay, now they are talking about interior angles. So let's first mark the interior angles. So these are our four interior angles. Okay, now these are not random interior angles. These are the interior angles that lie on the same side of transversal. In fact, let's highlight it. Same side of transversal, which means these two, okay, and these two. In fact, let's use a different color to highlight them now. So I'm going to just mark these two and these two. So let's zoom in and give some numbers. So let's say this is angle 1, angle 2, angle 3, angle 4. Okay. So same pair of, so pair, okay, let me use a different color. So pair of interior angles, okay, pair of interior angles on the same side of transversal. Same side of transversal is an important term. Previously, we have seen alternate pair of interior angles. So So the alternate pair of interior angle was 1, 4, 2, 3. Why is it called alternate? Because they lie on the alternate side of the transversal. However, this one is same side of the transversal. Okay. So we have two such pairs. So first one is angle 1 comma angle 3, and the second one is angle 2 comma angle 4. Okay, so before we see the actual property, okay, we have just noted down what are the same side pair of interior angles. Now let's see what the property says. So okay, let us try to okay. So let's read the property. Now the property reads, sorry, it's not a property, it's in fact a theorem. If a transversal intersects two parallel lines, so we have this transversal that intersects two parallel lines, then each pair of interior angles on the same side of the transversal, okay, is supplementary. So this is the keyword here, supplementary. We know what supplementary means. Let's try to zoom in. So supplementary means, what are the supplementary angles? The angles whose summation is 180 degree are called as supplementary angles. So what this theorem actually says is, let's come here. Yes, this theorem actually says that angle 1 plus angle 3 will be equal to 180 degree. Similarly, angle 2 plus angle 4 will be equal to 180 degree. They will be supplementary. That is what the theorem is saying. Now, since it's a theorem, we need to prove it. So let's try to prove this part. Do we have space? Yes. So the proof is very simple. Now we have to prove that summation of these two angles is equal to 180 degree. Now we know that 1 plus 2 is 180 degree. Why? Because they are straight angles. They are the angles on this straight line formed by this line. So 1 plus 2 is always equal to 180 degree. So point number 1, angle 1 plus angle 2 is equal to 180 degree. Why? Because they are straight angles. We call them straight angles. Angles which are formed on a straight line. Okay. Now point number 2, but angle 2 is equal to angle 3. Okay. This angle 2 is equal to angle 3. Why? Because they are alternate pair of interior angles. So I'm just going to write here alternate pair of interior angles. Okay. In the previous video, we have seen that alternate pair of interior angles are equal to each other. So let me use a highlighter here. So we have 1 plus 2, okay, as equal to 180 degree, but 2 is equal to 3. So we can substitute this 3 in this. Okay. So let's come down, and point number 3 is by substituting, or by substitution, I'll say by substitution, we will get angle 1 plus angle 3 as equal to 180 degree. Okay, and let me box it because this is a key thing that we have arrived at. So angle 1 plus angle 3 is equal to 180 degree, and that is exactly what the theorem wants us to prove, this thing. Okay, that angle 1 plus angle 3 is 180 degree, which means angle 1 and angle 3 are supplementary angles. So again, in the similar fashion, we can prove 2 plus 4 is also 180 degree. Why? Because 1 plus 2 is 180 degree and 4 is equal to 1 because they are alternate pair of interior angles. So 4 plus 2 will also be equal to this thing, will also be equal to 180 degree. Okay, so this is the theorem that we have proved, that for interior angles which are on the same side of the transversal, they will always be supplementary. Now we are going to see the converse of the theorem. We can guess what the converse is. The converse theorem will say, if we have interior angles whose summation is 180 degree, interior angles who are supplementary, then these two lines will be parallel to each other. So that's how the converse works. Let's read it. Okay, so if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary. Okay, so this is the given condition. Okay, that there will be a transversal which will intersect two lines and the pair of interior angles on the same side will be supplementary. If all these conditions satisfy, then okay, then what? The two lines are parallel. Then we will say that the two lines are parallel. So yes. So these two lines will be parallel to each other if this is supplementary. So again, this is the third property or the third condition that we have seen to prove that the angles are, to prove that the lines are parallel to each other. The previous one was if the interior angles, alternate interior angles are equal to each other, then also the two lines are parallel to each other. And the first one was if the corresponding angles are equal to each other, then also the two lines are parallel. So these are very important three conditions to prove that when two lines will be parallel to each other, which we'll be using in our exercises. So this completes the property of pair of interior angles on the same side of the transversal, that they are supplementary. Now, one last property that we want to see is called as three parallel lines. Now it's quite intuitive and quite simple to understand. First, let's read what the theorem says. The theorem says lines which are parallel to the same line, okay, parallel to the same line are parallel to each other. Okay, what this means visually is, let's say we have line number 1. Okay, I'm just going to write here line number 1, and let's say we have this line number 2. So this is my line number 2. Yeah, line number 2. Now, if line number 1 and line number 2 are parallel to third line, some other random third line. So I'm going to draw the random third line here. Let's use a different color. Yes. Okay. So let's say, and okay, let's name it line number 3. Okay. Now, yes, let's come here. So if line 1 is parallel to line 3 and line 2 is also parallel to line 3. Line 2 is parallel to line 3. So let's read the statement. Lines which are parallel to the same line. Okay, this is the important box that I've made. They are parallel to the same line, line 3, line 3. Then they are parallel to each other. Okay, so if this is the condition, then I'll say then line 1 is also parallel to line 2. Okay, quite simple and in a way quite intuitive. If line 1 is parallel to line 3, just think about it. Forget the theorem. Just think about the the geometrical statement or the geometrical fact. If you draw a line 1 which is parallel to line 3, then you draw line 2 which is parallel to line 3, then kind of obvious that line 1 will be parallel to line 2, right? These two lines will be parallel to each other. Similarly, if I draw another line, okay, one more line here, which will be again parallel to, let's say, line number 3. Let's call this line number 4 now. Okay, I have constructed line number 4 which is parallel to line number 3. Then line number 4 will obviously be also parallel to line number 1 as well as line number 2. Okay, so all these lines will be parallel to each other. That is what the theorem says. Lines which are parallel to the same line will be parallel to each other. So even these three will become parallel to each other. So this is an important property with respect to parallel lines, again, which we'll be using to prove that any two random lines given in a condition or given in any exercise are parallel to each other.